Hi. In this video, we're going to look at the relationship between the slopes of parallel lines and also the relationship between the slopes of perpendicular lines. So let's start with this example. We've got a line drawn here. I'm going to calculate, I'll call it L1, because in a minute I'm going to have some more lines. I'll calculate the slope. M1 will be the slope of L1. So I'll use maybe these 2 points here. So the rise is 1, and the run is -3. So it's a slope of -1/3. Okay, now I'm going to see what it looks like if I draw just another line with a slope of -1/3 in a different place. So I'll pick any kind of random starting point. Maybe I'll choose here. And I'm going to do a rise of 1 and a run of -3. Rise of 1 and a run of -3. Call this one L2. So we get there. We also have M2. Its slope is also -1/3. And these give us parallel lines. This kind of makes sense, that if we've got two lines that are the same amount of tilted, then those lines are going to be parallel. So lines with the same slope are parallel. Okay, now so that one's not super surprising, but I want to show you what happens if I draw another line. I'm going to call it line 3, so this will be slope 3. Here's what I'm going to do with this slope. I'm going to flip it upside down. So the 1/3 will change to 3/1, and I'm going to change the sign, so it'll be positive. I'm going to pick just another random starting point, maybe right here, because there's some space there. And look at what happens if I draw a line with slope of 3. So rise of 3, run of 1. Rise of 3, run of 1. Maybe I'll get one other point back here. These lines, I'm going to put the ruler here to show you, these lines are exactly perpendicular to each other. Maybe if I show in this direction. So they're exactly perpendicular. And it turns out that this is the relationship between the slopes of perpendicular lines. It's not super obvious why it would be like this, but they have opposite signs and they're upside down from each other. Okay, let's look at another example just to make sure that wasn't a fluke. So I've just drawn a line here. We'll call that L1. And M1 is the slope of L1. So if I choose maybe these 2 points, between these lines I have a rise of 3 and a run of 2. So I think we can see, and if you can't, just pause the video and draw one. If we started in another place, and we did a rise of 3 and a run of 2, we get a line that was parallel to this one here. Usually people are pretty quick to see that lines with the same slopes are parallel. But let's draw one with that upside down negative slope. So we'll say M2, so that I'll change the sign, and I'll flip it upside down. And then I'll just pick a starting place, maybe over here, because there's some space over here. So I'll do a rise of -2 and a run of 3. 1, 2, 3. Rise of -2, run of 3. And then I'll connect those. And I'll put the ruler in there. And we can see those are perpendicular. Those are perpendicular lines. So here are the conclusions from this. First of all, parallel lines have the same slope. They Okay, this one is slightly less obvious for people. Perpendicular lines have slopes which are, so what I did, I changed the sign. So I took the number and made it negative. And if the number started off negative, when I make it the negative of that, we get positive. So I changed the sign. And I flipped it upside down. So the way we say that is that they're reciprocals. Oops. Negative reciprocals of each other. So what that means, upside down negatives. For example, we might have a slope of 2, and the slope of a line that would be perpendicular to that, we change the sign and flip it upside down. 2 and negative a half. Or we might have, if we had, say, negative 3/4, a line that would be perpendicular to that, we'd change the sign, so it would be positive, and we'd flip it upside down. 4/3. So perpendicular lines have slopes which are negative reciprocals of each other. Another way to write this so if L1 is perpendicular to L2, this sign here, it means perpendicular, and it makes sense because they're two perpendicular lines. Then the slope of M1, the slope of the first line, what we can do to get that slope is we do 1 divided by the other slope. That's the thing that flips it upside down, and we make it negative. So that's a really shorthand way of writing that they're negative reciprocals of each other. And just one last thing I want to make a note of is if we had a line like this that's got a slope of 0, the perpendicular to that would be straight up and down, and that's an undefined slope. So let's just say, I'm going to put that in black, that lines with slope of 0 and lines with undefined slopes are perpendicular to each other. So lines with slope 0 are perpendicular to lines with undefined slopes. So it's pretty cool. This relationship, some parts of it are clear. If you drew this line, you know that that's got a positive slope. You know that the perpendicular line is going to have a negative slope. So the fact that they have opposite signs, that's not really surprising. And then maybe we'll look at this first picture again. Our original black line, it was pretty flat. It was a slope that was less than 1. It was less than a 45-degree angle. It was a pretty flat slope. And it makes sense that the perpendicular line would have a pretty steep slope. And that's the part that we get when we do the flipping, when we do the negative reciprocals. So, takeaway. Parallel lines have the same slopes. Perpendicular lines have slopes which are negative reciprocals of each other. Alright, good luck.